Hey, this question is number 11 on 7.3, pre-calculus 30. We're talking about exponential functions, and we're talking about solving exponential functions. And this particular question talks about money, value, investments, that sort of thing. So you don't see this very often in pre-calculus. So I'll do this question for you. So this is the formula that you would have seen in 7.3. A is the future value of an investment. P is the principal. And you've got 1 plus. Now this value right here is small I think they call it. And this is to the power of n. Now the little I here is it's the annual percent that is divided among how many periods there are in the year that it may be compounded. So for example, in this question, we have 8% per year. And so over here, I'm just going to draw this over here. So 8% is a decimal form of 0.08, right? And that is carried over the entire 1 year period. Now, if it's compounded quarterly, like it is over here, that means that every 3 months or every quarter, it's the interest is calculated. You don't get 8% for every quarter, okay? You get 8% for the entire year. So that has to be spread out over the year. So watch this. If you, for this part of the year, it's 8% divided by 4. And so that's where we get the 0.02 from. Now, n is the number of compounding periods. So if we're talking about in terms of years, because look at this is an equation we're looking for the value of the investment as a function of time in years. Okay, so what does that mean? Well, for A, all right, we can do A here if we want as the value, okay? You can do V or A or whatever, future value. The principal, in this case, is $1,000. All right, we multiply that by 1 plus. So the interest rate, you always use the decimal, and that's going to be the yearly interest rate divided by quarterly periods. So that's divided by 4 times per year. Okay, and that's where we got this 0.02 from. That's what that is. Now, this n is the number of compounding periods, and there are, the question wants years, so if there are 4 per year, that is 4t compounding periods, where t is the number of years. So this is to the power of 4t. Okay, and that's fine for A. Now, if you want to simplify that, you can write it like this, 1.02 to the power of 4t. Okay. So B, let's look at B now. B says determine the value of the investment after 4 years. Okay, well, the value of the investment is A. We're going to take our equation, and we are simply going to put in 4 for T. So that means that there are 16 times that this interest is calculated, right? 4 times 4 is 16. And so you get your A value there. And I'll let you guys figure that one out. I'll give you the answer at the end of the video. So make sure you can calculate that. And then C, how long will it take for the investment to double in value? Okay, well, let's do a different color here so we can separate these all. So C, basically the future value is going to be double our initial value. So that means it's going to be 2,000 because we started with 1,000. So we want to find out how long it's going to take, how many years, how long will it take. So you're solving now for T, and there's 2 ways you could do that, of course. You could plot or you could graph on graphing technology 2 different functions. This one, y equals 2,000, and y equals this one, 1,000 times 1.02 to the power of 4t or 4x or wherever you put it in your calculator. And then you could find the intersection point. Or another way you could do it, this is option number 2, is you could get everything over to the other side here and let the equation equal 0. And so you'd have this right here. Okay, minus 2,000. And then what you would do is you would simply graph that and then find the x-intercept. And of course your x value of the x-intercept will be your answer right there. That'll be the answer. Okay, so again, I'll let you try that. If you haven't tried that yet, I'll give you the answers in just a second here. All right, here we are back. Hopefully you got a chance to check that out on your calculator yourself. Here is the future value for letter B. 1372.79 is the dollar value. And then over here, I just plotted a little picture here of this one right here, where we graphed one single graph and found the x-intercept. This x-intercept, depending on you know, how you do this, you might get and like I say, if you just had one value for n here, then you'd get 35. But if you graph this the way we did, you would probably get 8.75 years. So this is the number of compounding periods. So some of you, depending on how you set up your equation, if you did it just like me, you're going to get 8.75 years. But for some of you, if you just wrote this as n, and understood this is going to be the number of compounding periods there before each year, then you might get this on your graph. All that said, you should get about 8.75 years. So that's question number 11 to deal with money value. So you should memorize this or put this on your cue sheet if you're allowed one for the test, and know what each one of those parameters represents.